experience, I would recommend the reading materials. If you're kind of intermediate, maybe the puzzles. Um, I don't know.
All right. Okay. I
Yeah.
got that fixed. Thank you. All right. So Java structure. So this can be kind of complicated, okay? But I just want you to know that this like workshop is meant to be kind of like a basic overview of everything. Sometimes it's going to be like a little scary, but like I promise you it's really not that complicated. And a lot of this will make a lot more sense when you see it in action on Monday. So we're just going to kind of go over the vocabulary, and I'm going to try to like explain this. But there are sometimes it can be a little intimidating. I just want you to know that it's gonna be it's all not that bad. So the first thing that most Java classes or all Java programs are divided into like classes, methods, and variables. So let's start with classes. Okay. So a class is basically where all of your code is going to be written. There can be multiple classes in a Java program. It's just kind of like, I like to think of it as like a folder system. So if you have one big folder, which is your Java program, you can go into that folder and there's multiple little folders. And so I have an example here, public class home. And basically, to write a class, all you have to do is, so there's like this public, right? That's just kind of a describer. Um, that, like, I'm not going to go into much detail about what that means. You just have to know that it outlines the accessibility of that class. So public means that it can be viewed by any other person. Like it can be accessed from any other place in the program, right? There's different ones like private, protected, and basically they have different functions to keep people from messing with your code when you don't want it to be messed with, right? So the class part is really important because in order to define a class, you need to say, hey, this is a class. And this home part is just the name of the class. And we're going to go over this a little bit more in depth in best practices, but it's good to make sure all your classes are capital because that just it helps identify them more easily. And then everything is inside these like curly brackets, and all your code just goes into the class body, right? So is that clear? Does anybody have any questions about like what a class is? Does that make sense? I know it's kind of like new to some people, but
Elena, your mic is a bit acting up.
it's acting up. Did you hear what I said?
No, like after like every 30 seconds or so, it makes a screeching noise.
Okay. That's not good. Let me unplug my earbuds. Is this better?
Yeah.
Okay. I guess I'll re-explain that then.
I mean, I heard you. It's just that every 30 seconds it makes a noise.
Okay, well, hopefully this stops it. So, okay, I'm gonna move on then. If nobody has any questions. Okay. So the next thing are methods, okay? So methods kind of manifest themselves in a variety of different ways. A lot of other languages refer to them as functions. Basically, they just do stuff. And they're going to be like, you can't have a method outside of a class. It's always got to be inside of a class. So we're going to go over the different types of methods and how to make one. So, okay. Here is like a little method that I just wrote. And all it does is it prints out a string, which is basically text. We'll go over the different types of variables in a bit, but methods are made up of describers, their name, their arguments, and then the code. So let's start here. Public string. Public, once again, is similar to like the class thing. Basically, it means it can be accessed from anywhere. String is telling you what the return value is. So this method is going to return text. There's different types of methods. Some can return integers, some can return decimals, others can return booleans, which is like a true or false statement. Some can even like return nothing, and you put void there, and it just performs an action, right? Lights on is the name of the method. So if you want to invoke this method or call on it, you're gonna put the name of the class, right? So I'll say home dot lights on, and then in parentheses I'll put what these are, and that'll call on the method basically. So here we have the arguments inside the parentheses, right? So notice how I'm defining the arguments as integers, right? So it's important that you define what your arguments are. So the first input that I need to give this method so that it works is the total number of lights in the house, right? And the second one I need to tell it is how many lights are on inside the house, right? So in this return statement, it's going to say there are, then whatever number of lights you said were on in the house out of number of lights total in the house. So it's going to say, so if I put in 3 for total lights and 1 for number of lights on, I could say there are, or I guess I should have used a plural one, but there are 1 light out of 3 lights on, basically. So that's what it's going to return, that string. Actually, I should have put a semicolon at the end here. There's always supposed to be a semicolon after a return line. I put that in bold, and I didn't even do it myself. Oh, shame. Okay. So is there any questions about how to define a method? And like I said, we're going over a brief overview, so you're probably going to have to do some research on your own and just get like accustomed to doing this. It's just important to kind of recognize these patterns so you can recognize what is a class, what is a method, and what are they doing, basically. So we're all good? No questions? Are there any questions in the chat? Okay, we're going to be moving on then. Okay, I just wanted to say this. There's a main method, and basically that's going to be in every single Java program ever. You need that. You got to keep it there. You don't have to worry about it that much for robotics programming. It's there for you, already made. Don't touch it. Just leave it. Just leave it. Yeah, it's just there so that the program actually runs. I just wanted to point that out. Okay. Now here's where things kind of start to get complicated. There's something that are called constructors, and they're inside classes, and they're kind of formatted similar to a method. I guess essentially they are methods, but they're like a special type. And so basically they define certain things about a class. So for example, I have public home, that's my class, right? Now, the name of the constructor is always going to be the same as the name of the home, even though it's same capital, everything, right? That's how you know it's the constructor. So it's a public constructor. Its name is home because that's the name of the class. Now, in this instance, all of the homes that I make are going to have a number of floors, a number of rooms, and an owner. And this part down here seems kind of redundant, but that's just kind of like the formatting of a constructor. You just say floor, the little like underscore underneath means just like this is subject to change. So floors equals floors, rooms equals rooms, owner equals owner. That's supposed to be an underscore. And so yeah, that's basically what a constructor is, right? So when you make an object, right, and we're going to go over like in more detail what an object is in the next slide. But this object here, you're calling it and you're making an instance of the class. So you're saying there is home, right? And it's called my home. And this is a new home, and it's going to have 2 floors, 10 rooms, and its owner is Lena. So does that make sense? Can somebody like say something so I know you guys can hear me?
Yes. Yes.
Okay, that's good, because I was kind of worried that like the mic or the speakers weren't working. Okay. So objects
kind of are weird, but we're gonna go over like what that really means. So an object is an instance of a class. So as you can see, I can make as many homes as I want, right? But they can all have different properties, right? So I have my home, and that's going to have 2 floors and 10 rooms, and it's owned by me. But then John can have a home, and he's going to have 3 floors and 15. And so, like I said, there's one class, but you can make as many objects as you want out of them. And the way that you basically define an object is you say, okay, the type is going to be the class. You say, what type of object is it? It's a home object, right? Then you say the object name. So the object name is going to be my house, John house, Crane home. Oops, my home. Yeah. Then you put an equal sign and then the new keyword. So the new keyword is really important because basically that's just saying this is being created. This is being instantiated. This is like coming into existence in this moment, right? Then you put the class type again with the parameters in it, right? And remember, these parameters were the things that were defined back in the constructor, right? So the floors, rooms, and string owner, right? So that's why the constructor is so important, because some classes, they might not even need a constructor. You just have to type in new home and then put nothing in the parentheses, right? But a lot of objects have inputs, and it's important to know what those inputs are, because it's not going to work if you're not giving it the inputs it needs to exist as an object. So those are the basics. I know it's kind of like scary. It's kind of weird, like the terminology, objects, classes, constructors. Like once you start recognizing patterns, it's going to get like a lot easier to understand. So we're going to move on to Java basics.
All right. So I'm gonna take it over here and talk a little bit more about the basic elements of Java that you want to put inside your classes and your methods and that structure that we just talked about. So let's. All right. So here we've got 3 of the basic elements of Java. So one of basically the thing that most of your code is going to be built on is variables. A variable is just a piece of information that's stored along with a name. So for example, you could say like a variable for however many apples are on this table. So you could just say this variable is called number of apples and it contains the information 5. So like you're saying that there are 5 apples. This just helps to like give your code meaning rather than it being just, you know, a stream of garbled information that you don't know what it is. So seeing things in terms of variables rather than information is a lot easier. And you can change the information that's inside the variable with keeping the same name so that it makes it easier to digest. Then we have operators. These operators are, it says they allow you to manipulate your variables and the information stored inside them. And that's sort of a little bit vague, but they have a lot of different uses. You know, you can use operators for different things, and they essentially come in the form of like math symbols or those the equal signs that you use to initialize variables. That sort of thing is what operators. We're going to talk a little bit more about them a little bit later. And then we have Java logic. Now Java is obviously built upon logic, but there are certain logical functions that we use in Java that we need to consider and think about. And using these functions sort of helps you understand how Java thinks. It dictates how the elements of your code interact with each other. So we're going to talk a little bit more in detail about variables and the types of variables. So we have, first type is integers. It's int. So, you know, an integer, you just have a number that is not a fraction or a decimal. So, you know, integer x equals 4. This would be good for if you're doing something like the number of apples before. You want to have a definitive number. Like, you don't want to have 4.6 apples. Like, you want to have a certain number. But if you do want decimals, then you can store that information under a double. So a double is just like an integer, but you can have decimals with it, which opens up a lot of possibilities. We use them a lot because we use a lot of decimal readings, you know, for robotics. We also have strings, which Elena mentioned just a second ago. A string, it stores a text. So rather than like a number or something like that, you can say this string, my team equals Falcon Robotics. So, you know, you can add that into a string of text that is somewhere else. It's also the only type of variable here that's capitalized. All the capitalization is intentional, or lack thereof. And then we have a Boolean variable. A Boolean is very multi-purpose, but it stores a true-false value. Yeah, 0 and 1. So you can essentially just have, they're usually titled after like statements. So the Boolean code is cool, just to, you know, let you know the code is cool. It is true. So, you know, you can use this to, like, as a condition for if statements, which we're going to talk about a little bit later. They have a lot of different purposes that you can use them for. Next, we're going to talk about operators. There are 3 types of operators that we're going to talk about right now. We have the arithmetic operators, which are used a lot. You know, it's just simple math, usually like for just simple operations that you need to do. We have assignment operators, which mostly consists of just the equal signs, but assignment operators with a single equal sign is only used to like not initialize, but to assign a value to a variable, or assign two variables as the same. So so if you can think about it as when you might think of using like a single equal sign, like to say like these two are equal. This equal sign makes that true rather than asking if that's true. And then we have these mathematical operators. So we use this a lot in robotics because there's a lot of more complex math operations that we need to do. So there is a math class that has a lot of these operations in it. So we can go into a little more detail about these operators. Next slide. All right. So arithmetic operators, there are a few types of these. You have, you know, your plus, minus, multiplication and division. There's also an operator called modulus. Modulus is represented by a % sign, and it essentially just means the remainder of the division of two numbers. So you can do basic math with these number values and variables. This can be useful, like if, say you have, you know, integer z, which is always going to be the sum of x and y. You could also have like a number that if you know that this number is always going to be another variable divided by 3, then you can assign that value to a variable using these operators. You can also use them just like to do operations if you need to. So they can be used for a lot of purposes. They're just simple math operations. Then assignment variables, they're pretty simple. We talked about them. assign a value to a variable. So like integer x equals 4. With the more complex math, so Java has this math class. It's a class called math, which is not the same as like math class. So you can call these methods from the math class. So like in the slide before, I used the absolute value method as an example, the math.abs of x. And so that would return the absolute value of x. Since it's a method, it when you call it, it just returns what it's supposed to return. This I use the square root. So there are a ton of methods that you could use, like from like simple like square roots and absolute values. You can do like logarithms. You can do trigonometry. There's a lot of things that they've included in this class for you. So next, we're going to go sort of into the Java logic. We have some of the elements of logic here. The first thing to understand is if statements. If statements are very, very frequently used. It's just essentially saying, it says perform a task if a certain condition is met, which they're essentially saying, if this is true, then do this. So the example I have is if code is cool. When you put just the Boolean variable name, it's asking if that Boolean is true. So if this is true, code is cool, then system out print yay. So if the Boolean value code is cool equals true, then it'll print that out. There are also other versions of it. So you can say if code is cool is true, system out print yay. And then you can have an else if. So an else if you put under this if statement, and you essentially are saying if that first condition isn't true, but this second condition is true, then do this second, run this second line of code. And then there is else. You can put this after an if or after a series of ifs and else ifs. Else is just saying if none of the conditions are true, then do this instead. This is the default if none of these are true. And there are a lot of ways to create those conditions. You could say like if this Boolean is true, you could use some of the logic operators down here. I'll talk about that in a second. You could say like if integer z equals like integer x plus y, then if that is true, then it'll do it. We also have loops. So if you want to run a series of code repeatedly, then you can use a loop to do that. So there are two main types of loops. There are while loops, which they repeat when a certain condition is true. So they're essentially like if statements, but they, instead of running a code one time when the condition is true, it continues to run the code until the condition is not true. And then there are for loops, which you set a specific amount of times that they run, and then it'll run that number of times. And one thing to keep in mind is that even if you're running the same code over and over, you're not necessarily performing the same task, which is sort of a weird thing to comprehend. But like inside the loop, you can change a variable, and when that variable is changed, it will be the new value the next time the loop runs. So you can sort of change what the loop does as it goes on. It's sort of weird to think about, but yeah. And then we have logic operators. These are just as often used to set conditions because they have different meanings. This and this could be used. So when you're saying, let's put this in an if statement. So let's have two Booleans, like code is cool and I like Java or whatever. If you say if code is cool and I like Java, you are essentially saying if both of these Booleans are true. And you can do this with other conditions too. So the if statement will only run if both of them are true, and if either of them isn't, then it won't. These double vertical lines are more of an or. So you can say if code is cool or I like Java. Then if either of those variables are true, then it'll run the statement. It'll only not run it if neither of them are true. And then we have this exclamation point. The exclamation point in Java essentially is saying not. Like, so if you say if exclamation point code is cool, then you'd be saying only if code is cool is false will you run this. And you can combine that with these other logic operators. You could say if code is cool is false, and if I like Java is true. The double equals sign, which I mentioned before, you can put this like, you can put in a condition if, integer number of apples equals integer number of oranges, whatever. Then you can run this code. And that is checking to see if two things are equal. So that's the difference between the single and double equal sign, which is if you use the single equal sign, you are making it true that two things are equal. And if you use the double equal sign, you are checking to see if two things are equal.
All right, so here are some things that you'll want to do when you're coding. So first are comments. They basically help you like summarize or add detail to your code for people who read your code or for their future self. So like here we have the double forward slash or the forward slash star and ending with the star forward slash. So under the example, there's two slashes, this comment of the whole line. That basically means that none of that will become part of the code, but if you're reading the code, you'll still see it. And for the star and the slash, you can put it anywhere in your code as long as it has an end to it as well. And it can go for multiple lines. When you're naming things, variables should be named so that anyone reading it can understand what it is. So don't name your variables X and Y because that's super vague. Maybe your variable could be number of apples on the table. That way it's super clear to whoever's reading it. Same thing goes for methods in classes. So like just make sure that whoever's reading it understands it. I think this one is yours, Lena.
Yeah, I was just unmuting myself. Sorry about that. So, name capitalization. I know this seems kind of trivial, but there's Java conventions, and it's called camel case. I recommend looking that up and kind of showing how what is what basically. So classes, like I said earlier, always going to be first letters capitalized. Variables, they're always like completely lowercase. One constant is, okay, this is kind of weird, but there's types of variables which can be constant, meaning that they're not variable, like they're not changing. And so they're still signed in the same way, but the name is traditionally put in all caps, just so you know that this is a constant, this is not changing. We'll show you some examples of that next time on Monday. Methods, so the first word is always lowercase, but every word after that starts with a capital. So like if you have turn on lights, turn would be lowercase, then the O and on would be capital, and the L in lights would be capital. Indentation. Okay, indentation is also a really useful tool because it it helps you like group things together, and it shows you like what is part of what, right? So this is an example. I know it looks a little scary, but it's just a for loop, right? And so all this is saying is like, okay, so this if statement here is inside this for loop. So if you see those brackets, right, the brackets define the code that is inside the if statement. So inside the if statement, you have system.out print line even, and then within the for loop, you have this if statement, right? So the indentation shows you what is part of what. And there's actually, I think, a shortcut to like do that. I can't remember it off the top of my head right now. We'll talk about that on Monday,
Might
though.
be
Like,
Control Shift or something.
I think it's like Control Shift F, like format, I think. So yeah. And so yeah, that's about it. If anybody has any questions, we finished a little earlier than expected, but I don't think that should be a problem for anybody. If you have any questions, go ahead and ask them now. And we're also going to be posting the post-workshop survey in the chat. Can John or Crane, can you do that? Let's see. I'm going to go back to the Zoom. Let's stop share.
I have a question.
Okay.
So so if you're using Visual Studio Code, how do you execute the code?
Okay, so we're going to talk about this a little bit more on Monday, but it kind of works through a process called building and deploying. So basically how it works is you have all of your code, your robot code in VS Code, right? And then you basically when you're setting stuff up, you are gonna make you're gonna give your robot either like a Wi-Fi, like you're gonna set up the radio so you can connect your computer to the radio. And so you hit Control Shift P and then you type in like build deploy code, and when you hit that, it'll take all your code, it will put it into a nice little package, and it'll send it over to the robot. And so now all that code is on the Robo Rio, which is like the brain of the robot. And so when you open up the driver station, you can like start teleop or autonomous on the driver station, and you can test out your code. And so for regular Java programs, you obviously don't need to do this. You just need to like run it. But you can't run robot code on a computer unless you have like a simulator or something. So you're gonna like actually execute your code by sending it to the robot. Thank you for your question, though. Does anybody else have any questions? I guess that's good. I don't know. I feel like
Do all of you have access to the post-work survey?
you can say yes or type it in the chat.
If you have access, then you can raise your hand, and we'll see that.
Oh, also, Dervish Abrams. I'm sorry if I'm pronouncing your name wrong. Do you have your hand raised? Are you trying to ask a question?
I think I already asked the question.
Oh, okay. Okay. So I'm just gonna lower that then. Okay. I wasn't sure if you had another one. All right, cool. Well, we're gonna use the Google, I think your emails that you used in the registration. We're gonna send you this, and we're also like the presentation, and we'll also send you a video of this presentation. Thank you all for coming. I really appreciate it. I hope we helped you. If you have any questions about anything that you just didn't think of, you can email us. You'll get the email when we send it to you. So yeah, just thank you, all of you.